Okay, now we're going to quickly discuss about the last video, hopefully, I'll be making about speed, or velocity, I should say, acceleration and position in terms of calculus. So, if you guys remember from pre-calculus when we talked about vectors, when you would have it in this formation, let's say it was 5, 3, well, that would mean that the vector had an x displacement of 5 and a y displacement of 3, so the vector looked like that, where this would be 5 and this would be 3. Well, to express vectors, you actually use vectors to express acceleration, speed, and velocity. So for example, you can actually have vector equations. So let's say, for example, there's a function where v of t, I'm making up all the problems for this here, so hopefully this all work out, is 2t and then like t squared minus 3. As in, so in this equation, as time goes up, this is still kind of parametrics, as time goes up, the x displacement is going to be, or I guess the x velocity is going to be 2t, while the y velocity is t squared minus 3. To find the acceleration formula, we're going to take the derivative of these. Think of it like this. This right here, because velocity is the derivative of position. I put position as an S. I don't know why I'm going to make it a P. Because of this, this can kind of be considered dx dt and dy dt, because typically the p of t would be the normal equation, velocity with the derivative, and the acceleration would be double derivative. And because this is in terms of x, this is in terms of y, this is kind of like dx dt, and this is kind of like dy dt. So because of that, we can find acceleration by saying that acceleration, a of t, equals the derivative of v of t, which equals 2t, like that. To find the position equation is a different story. A lot of times the question will say something like, find the position if the original point, so let's say, find p of t if at time equals 0, the point is at like 0, 4. I don't know. Well, because the reason is because you're going to get c's. So p of t equals the antiderivative of this, which would be t squared plus c, because you're doing an integral, a definite integral, or an indefinite integral, so there's going to be a c. And then this one, which would be 1/3 t cubed minus 3t plus, and I'm going to write d, just because I want something, because these are going to be different constants. And now it's time to plug in numbers to find out what the equation is. And then, of course, you can use the equation to find what point it's going to be at when t equals any value. But let's then say, well, at p of 0, this is like 0, 4 equals c squared plus c 1/3 t cubed minus 3t plus d. I hope this works out. I kind of didn't check. So t squared plus c equals 0, so, wait, that was stupid, because then I should plug in zeros for these, so this would be 0, 0, 0. So you're going to get 0 squared plus c equals 0, so c equals 0, d equals 4, because these are 0, 0, that d equals 4. So then you're left with p of t equaling t squared plus 0, so I guess I can just write t squared, comma, 1/3 t cubed minus 3t plus 4, like that. So then what if the question says, when is the object at rest? Well, that would be when the velocity equals 0, obviously. We'll say this is 4. But think about it like this. Because of this is the position in the x direction, this position in the y direction. This is the velocity in the x direction, this is the velocity in the y direction. If this is 0, but this is still something that's not 0, then it's still moving in the y direction. We want it to not be moving at all, so you would have to find when this is going to equal 0 and when this is going to equal 0. So what you would have to do is you have to say 2t equals 0 and solve for that, and then t squared minus 3 equals 0. in this case t equals 0, and this one t equals plus or minus square root of 3. Obviously, these don't share anything in common. There's no common time when they're both going to be 0. Therefore, this object is actually never going to be at rest, at least for positive times, because time can be negative. I guess I didn't even have to say that. And then the one last thing I want to talk about is finding the speed of an object. Now, I understand you're thinking, velocity is right here. What's the difference? Well, velocity is a vector. Velocity includes direction. What if I want to know speed? Like, what is the meters per second at a certain value? Well, there's actually an equation for this, and luckily, we only need the v of t equation. Why? Because this right here, once again, I'll write it again, this is dx dt, and this is dy dt. The equation to find velocity at a certain point, we'll say what's the velocity at 3 seconds. You do this to basically show that this isn't a vector, this is a scalar. This is going to equal the square root, this is very similar to the one we just did, of dx dt squared plus dy dt squared. But of course the difference is that now we're actually plugging in 3 for these. So you would get 2 times 3, so this would be 6 squared, plus 3 squared minus 3, which would be 6 squared, actually. So this would be the square root of 72 units per time. So I'll say units per time. I don't really know, but you get my point. It's be like meters per second, something like that. And so that's how you find speed, and that's how vectors work with position, velocity, and acceleration.